So, moving on to today's lesson, our driving question is going to be what are homogeneous and heterogeneous mixtures and how do they fit into our understanding of matter? Our objective is to be able to define and identify heterogeneous and homogeneous mixtures. And we have a little assignment that we're going to do after today's Nearpod slides to complete that. So if you saw today, we're adding to our student notebook. We're adding 2 new vocabulary words as well as a few other slides. So make sure you check in the Schoology folder and copy and paste those things into your student notebooks. So the first vocabulary word that we're looking at is homogeneous. And homogeneous is a mixture that has the same appearance, composition, and proportions throughout. I believe your Edpuzzle talks about this a little bit, but an example of a homogeneous mixture would be orange juice. If we take a look at a glass of orange juice, we can see that it appears the same throughout. The proportions are the same throughout. Pretty much as far as we can tell, at the top of the orange juice glass and at the bottom of the orange juice glass, there's nothing different. It's all the same. And of course, our next word is going to be heterogeneous, which is a mixture that consists of visibly different substances and proportions. It does not have a uniform composition. So what that means is, if we think back to the video that I had in our lesson the other day, trail mix is an example of heterogeneous mixture. I suppose if we think to orange juice with like pulp, that would be heterogeneous because the pulp in the orange juice, that's not the same throughout. It's kind of like a different proportion throughout as well. But I think the best example that we have would be the trail mix. It's composed of those different pieces. They aren't mixed together in any way other than just being kind of close to one another in a contained space. So if you remember back to the last Nearpod presentation that we went over, we had the video that I put up, we had a glass of salt water. And I said, how do we classify salt water? And it's kind of confusing because if you think about it, salt, we know, is a compound. So salt, NaCl, is a compound of 2 elements. And water, H2O, is also a compound of 2 elements. But what we're asking is, how do we classify salt water? Is it a mixture, compound, or element? Well, if you put salt into a glass of water and you stir it up and the salt dissolves, it becomes a homogeneous mixture. However, when you first put in the spoonful of salt, it's a heterogeneous mixture because all the salt is kind of sitting at the bottom. You can see it's not the same throughout. It hasn't become sort of the same consistency throughout the entire glass of water. So today what we're going to be doing is thinking a little bit more closely about what other types of mixtures we can think of. Taking a look at some of our answers to the Edpuzzle questions, I want to make sure that our understanding of these concepts are clear. I don't know if some people kind of sped through the Edpuzzle or whatever, but it looks like we're missing a lot of questions regarding the classification of the different things that we're looking at. For example, what is aluminum? Is it a element, compound, or mixture? We were getting a lot of those things wrong. So I want to use this slide to kind of go over those things because we have to make sure that we're tying our understanding back to these fundamental chemistry foundational understandings that Mrs. Bennett has laid out for us, the periodic table. And what we're moving towards is how these elements are interacting with one another. And eventually what we're going towards is how do we process these elements, compounds, mixtures, and things like that in terms of like food and things like that. How do our bodies take these things in, and how do they convert them into energy and fats and things like that? So that being said, a couple reminders. Elements. I'm not sure if Mrs. Bennett referred to them as this or not, but often they're referred to as the building blocks of all matter. If we were able to cut things in half, anything at all, anything in the world, as many times as we possibly can, at some point we would get to the very end of cutting those things in half and we wouldn't be able to cut them in half anymore. At that point, we would have an atom of an element. because we can't cut it any further. It's the simplest building block of that piece of matter that we were cutting in half. Think back to the periodic table. And if you haven't, Google the interactive periodic table and make sure you bookmark it, because it's going to be important for you to be able to reference that moving forward. Compounds consist of two or more elements and are represented by a chemical formula H2O. So if you look at the right at these pictures here, I have neon taken from our periodic table, and we know that neon is a building block. It's the simplest form. Neon, it can't be simplified any further, right? Compounds, you see I have a picture of compound, the one that we've been talking about the most, water, H2O. Compounds are two or more elements, and they're represented by the chemical formula H2O, because we know that that formula means the H is the hydrogen and the O is the oxygen. And if you take a look at this molecule of water, we can see visually through this model how these things can be separated further. Now, last, the thing that we talked about most recently, mixtures deal with like a physical combination of things without any chemical change. Remember, we talked about how water, it takes on different chemical properties. A mixture, think back to the trail mix. The M&Ms are still the M&Ms, the raisins are still the raisins, and the peanuts are still the peanuts. We're just kind of throwing them in a bag, and that's what the mixture, that's where that idea comes from. It's a physical change. So looking ahead again, like I said, we're moving towards how do all these things interact with one another? How do these different elements create compounds, and what does that entail? I want to talk about how it relates back to our understanding of matter. And I thought this was a really good diagram that illustrates that. So matter can be split into two categories: pure substances or mixtures. Now, under pure substances, we can see we have a picture of elements. And elements, as we said, can't be broken down any further. They're the simplest building block of all matter. And if you take a look at the picture there, it illustrates that quite well. Whereas a compound is two or more elements brought together through a chemical reaction of some kind to make something different, takes on new properties. And if we look at mixtures, we know now, based on the slides from today, we have the homogeneous mixture and heterogeneous mixture. And the difference between the two is that homogeneous, it appears to be the same throughout, where the heterogeneous mixture, you can visually see the difference throughout. It's not the same composition or proportions throughout the entire mixture. So this chart right here is very important to have in your student notes. Now, for today's assignment, if we take a look in our Schoology folder, you'll see assignment. I'm actually going to see if I can go to that in just a second. But I want you to complete the assignment in today's Schoology folder and take some time to look around your house to find one mixture and one compound. Use Schoology and internet resources to help you if you need them. So that means your periodic table. Use that if you need help finding a compound, or what your compound that you find, what it's made out of. Now, let's take a look at the assignment here. I'll see if I can pull it up for us. So this is what the assignment looks like. And the directions are here. I've provided an example. That we've been using quite frequently. So you can see the compound that I found is water, and I included its chemical formula H2O right here. And I said, what elements are in this compound? Hydrogen and oxygen. And then I included what those two atoms for those elements would look like. What mixture did I find? I used the example of mixed salt water. And is it homogeneous or heterogeneous? How do I know? And I said it is homogeneous because it's been stirred and the salt has mixed with the water. If you look throughout the glass of salt water, you can see that it's the same throughout the mixture. I can't remove the salt. Little typo there. Now I know that it's a homogeneous mixture. So once you go through that, you cannot use my example for your example. but you'll be answering the same questions. What compound did you find in your house? Include the chemical formula. What elements are in this compound? And then I'm going to ask you to copy and paste an image of what the atom of these elements in the compound would look like. What mixture did you find? And is it homogeneous or heterogeneous? How do you know? So that's our assignment for today. If you have any questions, please let me know.